Good afternoon, this is Jim Snyder going over my spaced game done on the Unity 3D engine for the week 1 and 2 project for emerging technologies for mobile games. This here is the Galaxy Nexus provided by the school, and let's see, get back home here. The game is called Spaced. It's a very simple, straightforward, sort of side-scrolling avoid the asteroid game. Pretty simple. You want to stay away from the asteroids as they come down the screen. Let me just reset the data here. So this is how the screen would come up normally if the game had just been fired up for the first time. The three options, start game, reset data, and quit game. Only two of those would be in the final version, start game and quit game. The reset data there is just for testing purposes. So, but basically, the game, you hit start and you use the accelerometer to avoid, or you're supposed to avoid, the asteroids, as I do a very lousy job in it. And so if you get a new high score, it records your score, and also the latitude and longitude at which the score was taken in a much better version that would actually convert to a city and state, but when we discuss the code I'll talk a little more about that. But so, start the game over, and again it's, well, and here we go, losing again. I sort of feel like this is an interesting version of the game, or an interesting game just trying to avoid getting hit. I've actually gotten pretty decent at it. Maybe I think the top score I got was like a 25, but yeah. The motion on it's pretty straightforward, pretty easy to do. And there we go. Got a 9 on that one. I like how well Unity handles the accelerometer. I guess there's a little cruelty in how quickly the game will throw a fast asteroid, but it's all random. Yeah, a little more time and I would do stuff that prevented sort of some of that, but yeah, just for a pretty straightforward game. It definitely fulfills the criteria. So of course I'm trying to play this while watching through a camcorder as well, so it's a little more difficult, but anyhow, so that's the gameplay, and we will discuss some of the code in just a moment here. So to start looking at the code behind the game, I want to start with the main menu, which is basically the only code that is running behind the scene menu, which is the first scene that Unity fires up when the game begins. Essentially all that's going on in here is that I do some dynamic positioning calculations. I set Unity to playback in a 16:9 ratio, but everything inside of the game so far as the actual gameplay goes is set to that 16:9 ratio, and also the display, but the game elements themselves actually work in world coordinates, whereas GUI elements work in screen coordinates. So I'm just using this to sort of make sure that items are placed on the menu in the spaces that I would like them to be at. The actual GUI itself is pretty straightforward. This is the code that handles all of the buttons and the logo, as well as the display of the high score if one is present. Very straightforward to use. To implement a button, you basically tell it where to place it, what you want it to say. You could also include a style or a skin, which is something I'm still sort of playing with. I did use styles for a lot of the text stuff, but and then inside of the method you simply put what it is you want them to do when they are clicked, or in this case touched. Very simple, straightforward. The one that's on there that would be removed from a release version is reset data, which basically I'm storing all of the high score and location information as a line item, or two line items within player preferences, which is a simple key and value table reference that Unity handles itself. And so this reset data button simply deletes all of that so that I can for testing purposes, get back to a fresh install, basically. And then down here, the high score display line only shows if there's a high score greater than 0, and then it will show whatever information is stored, the GPS location data and the high score itself. So that's the code running behind the main menu, and next we will tackle the movement of the actual character. Before I talk about the movement of the player's ship, I'd actually like to talk a little bit about a quick trick that I did to cause the starfields to move. So this is basically a script that's attached to the plane that the starfield is on, and basically all I've got are a couple of textures. You can only really see one because I need to do some artwork on the second texture, but I wanted to focus more on the game at a certain point. So here is a reference to the main texture and the self-illumination map. Basically, that's what the starfield consists of, the star graphic itself, and then the self-illumination so that it can be seen without having to be lit by a light source, so that they actually look like stars. There's a second material which is basically it's sort of a cloudy thing that goes over it, and you can just barely see it. I would like to pump that up for a future release if I were to tackle this further, but not so important for right now. But basically what I'm doing is at a certain speed, I'm simply offsetting the texture so that it continues to scroll and gives us sort of that illusion of the starfield moving. So just wanted to talk about that briefly to explain what I did behind that. Now on to the actual movement of the player. Basically this is the part that implements the accelerometer from the Android devices, and basically on the move ship, which is called basically here every update that is called by the Unity engine, it will check to see if the ship is destroyed, and if it is, it will move the ship. If it's not, it will keep the ship hidden. Basically a cheap way for me to get the ship off screen without actually having to destroy the object and instantiate it later. Obviously, if this were a more in-depth game, I would actually go through those steps, but because this was just a simple, straightforward game, I was trying to put those components together as quickly as possible. So under here, under the move ship method, this is where the accelerator is called, and it's a very straightforward call. As you can see here, it's simply input.acceleration.x, which is just calling from the accelerometer for the difference on the x-axis. The reason it's only x as opposed to all three axes is because I'm simply using it to move the ship along the edge of the screen. If I were doing something a little more like rolling a marble across the screen or something, it would not be difficult at all to get any of that information out of the accelerometer. What I did find interesting is that in researching the use of the accelerometer, if I were implementing this in the native Android platform, there were a lot of suggestions for scripts that would basically smooth that input, because it's a very precise input that the accelerometer returns, and so a lot of times the movement will be jerky. However, inside of Unity, the engine actually handles that for you, and so what you're getting back is a very smooth value that's already been taken care of for you. The code that I saw on the Android end of things was not at all intimidating. It would have been very easy to smooth it out, but it is sort of nice that Unity handles that for you without having to go into any greater detail. So again, very nice and easy to put that in. Here, this ship position, that's basically, again, because the game is designed in world space, rather than having to input colliders, have a couple of collider objects for the ship to bump into and not pass through, because of the limited range of the ship, is easier just to set, negative 14z, I believe, I don't know, negative 14x and 14x as the boundaries within where the ship could move, and so if it tries to exceed that, it just stays at either end. So that way it ensures that regardless of the device size, it will always be on those two edges. So very nice way to do that without wasting time on collision for that. Just a couple of other things. The reset ship, this is just after you've played the game the first time and you go to play again, it puts the ship right back where it's supposed to. Nothing exciting there. And then the hide ship, this actually handles not only hiding the ship but also exploding the ship off the screen, showing the particle object and destroying it after it is played, so that it only plays once. Now, it also allows me to not have to actually destroy the physical game object, as I mentioned earlier. So that's basically the information behind the destroy ship, or not the destroy, the ship movement that helps implement the accelerometer to facilitate gameplay. So the next part that I want to talk about is the actual scoring object. It's a blank object that I placed out into the playfield just to keep track of a couple of different scoring functions, as well as the GUI that displays the score and also the game over or high score screen. So basically, again, some dynamic positioning stuff for the GUI portion of it. I have the score variable here, which gets reset to 0 when the game starts, and just places the score tag in the upper right corner, as well as the game over text. A static method to be called that increments the score. That's actually called from the asteroid class, which I'll talk about in just a moment. And then basically a couple of methods for game over and high score, basically just saying whether or not a new high score was detected or the game over, and this is purely the text display. And then finally grabbing the score from the class itself. So just a pretty straightforward class that's attached to an empty game object in the middle of the field that ties in a lot to the final script that I will go over in just a moment here. The final bit of code actually covers the asteroid itself. Basically, for purposes of this game, I just have an asteroid object on the playfield. I could have used several and added slightly different modifiers to them, but just for the simple scope of this game, it just is an asteroid that continues to move across the screen, and when it gets to the other side, it pops back up to a new random location, flies across the screen again, and the player has to avoid it. Again, this was more for the simple scope of getting the game out and running, rather than trying to come up with anything too complex. But so for the purposes of what I was trying to do, this worked very well. A couple of things that are in here, just the start and end range here. Basically, again, our world space coordinates, where the start is where the position starts on the z-axis, and the end is where it disappears from. If it goes beyond that range, then it will trigger a score if the ship has not been destroyed, and in either case will reset back to the beginning. And then the asteroid speed starts at a speed of 1, but actually can be variable within a random range, so that's where you get some of the some of the mean ones that fly across and just look like they're about to kill you, and some of them just sort of dally across the screen. But it's all just one asteroid repeatedly, sort of an economic use for the object. I've got an audio clip that plays on the ship's explosion, and when it first starts, it just puts the asteroid in place and gets it ready to roll. Then on update, it actually starts moving the asteroid based on the speed. The speed eventually becomes random down, well, here, if it goes out of range, as long as the ship has not been destroyed, it will increment the score. Otherwise, if it goes out of range, it'll go back to the beginning of the range. It'll choose a new random X position, which is the, as far as the screen goes, the width of the screen. And then it will do a set speed on it, which is just basically down here choosing a random speed range between 25% and 100% of a speed of 1. So speed of 1 moves very quickly. 25% of that, or 0.25, is closer to the just sort of crawling across the screen end of things, but give a little random nature to it. If the asteroid happens to hit the player, a few things happen. First, it sets the game, or sets the ship to having been destroyed. It plays the audio clip, and then it will check the high score. If the high score is greater than the stored high score, then it will handle a new high score, which I'll talk about in a moment. Otherwise, it just puts up the game over information. So as far as the high score goes, this is where GPS info comes in. And the GPS, as I found in this, for Unity, it was very easy to implement as far as pulling the GPS data, latitude, longitude, height. Unfortunately, what I also discovered is that using that information, or using that data to provide the user with some good information, not so easy. There were a couple of examples where this information could then be taken and toss somebody over to Google Maps, or to hop over to a web-enabled thing, something that would take that data and make some use out of it. A little bit beyond the scope of this game, obviously. But something very easy to do. It would just take this data and then pass it on. But as far as doing something as simple as getting a location, useful location like a city and state, like Bolingbrook, Illinois, or Winter Park, Florida, that was not easy to do, because all the Unity link does is just grabs that raw data. Now, in my research, I did discover that there are plugins available that sort of handle all of that for you, to turn it into a useful city-state combination. Unfortunately, because this is the basic version of Unity as opposed to the Pro version, doing a simple plugin was not an available option, at least as far as I read. I didn't find any that I could just simply drop in and handle that for me. By comparison, while reading up on the GPS information inside of the Android development kit, it seemed like if I were working natively in Android, and again I haven't tested this yet, but it seemed like if I was working natively in Android, getting that actual city-state combination from the pulled GPS data would actually have been a heck of a lot easier. That's actually a function call inside of the Android development kit. So I'm not entirely sure why there isn't a link between Unity and that development kit. I truthfully don't know how to deal with it going back and forth between the two. It is something I would like to research further. But getting just the basic GPS information out that was very nice and straightforward. So for terms of this game, I just read the sensor and plugged it in, as a here's your latitude and longitude. Obviously, for a retail release, or I would want better information, but I sort of went with what I had. Now, one thing that I did bump into, this wait for service, which basically calls up a coroutine for waiting, which basically just has it wait for a second, and then it's just to make sure that if the GPS service is enabled, it's given time to pull back some GPS information before failing. I did experience something interesting, and I'm not sure why, and it's something I'd like to play around with more, or just simply don't have the time to at the moment. But my initial test device for this was my Samsung Galaxy S2 phone. And when I installed this portion of it and started testing it, everything worked smoothly. There were no issues with it. Obviously I turned my phone's GPS on. Everything just worked really well. When I put this same stuff on the Nexus tablet provided by the school, and also on my Samsung Galaxy Note 10.1, in both cases, the first time I played the game and lost, the asteroid collided with me, the game hung. And at first I thought, because it wasn't clear whether it was, the particle effect or the sound or the GPS. It really wasn't clear. I was sort of wondering which area it might have been, but I've come to believe just through multiple iterations of this that it's probably something in the GPS, because strangely, after so it would hang, I'd exit the game, try to go back in, it would continue to hang because obviously the application had not been exited properly. Then it would bounce me back, I'd try to play again, the exact same thing would happen. As soon as I reset both devices, the Nexus and the Galaxy Note, would bring the game up and it would play just fine. Now, I'm not satisfied with that as a solution, because clearly I wouldn't want to have to put instructions that say, if your device crashes on this particular part, just reset it and everything will be fine. That's not a reliable, stable way of doing this. So I would look into it further. I'm not entirely sure what is causing it. It could be as simple as something as the hook between Unity and the Android native call, but I truthfully don't know. It's something I would love to look into more, and definitely will in the future. But again, just the basic use of the GPS itself, not very difficult. It was very easy to get. It would just need to be sort of brought to that next level, but all of that kind of stuff is things that with more time it would be much easier to do. So just that core data piece is so easy to pull that it was definitely a lot less worrisome than I thought it might have been to begin. Just a couple of other things. I think, let's see. Actually, I guess that's everything that I wanted to cover on that script. I guess the last thing is are these enumerators for the waiting. For this, when you're destroyed, I have the game wait 5 seconds before returning you back to the main menu, and then this enumerator is used for waiting for the GPS to respond. I guess in JavaScript, there's an easier way to do it where you don't have to have this separate enumerator to sort of pass something on and wait for it to happen. But with the with C#, it was necessary to use a separate enumerator to sort of wait for those seconds and then perform whatever action afterwards. There was a little bit difference in what I was researching on how to wait for this and actually how to do it in C#. Again, not a huge deal, but something that if someone is using C# as opposed to JavaScript should probably be aware of. So that really summarizes everything going on. Just a couple of other small things. Obviously, if this were a full release of the game, I would like to have done, some more text box stuff, like when the player gets a new high score, ask them for their name. That really is more of becoming more comfortable and more familiar with the Unity GUI pieces. Something I'm certain that a little more time I would be able to do, but the one thing that I was really impressed with in Unity is just the ease with which many things are able to be done. The engine handles so much for you, and exporting to the Android device through Unity was so much easier than I really expected it to be. So I guess that's the concluding thought, is just that for something that could be cross-platform, a lot of what I was seeing, it would be quite as easy to implement it within iOS as well. So definitely look forward to future projects, and I'm really looking forward to seeing how Coco's 2DX sort of compares to Unity, and also what some of the differences are. So definitely looking forward to get starting on the next thing. Thank you very much.